This is Mrs. Dever, and today we are going to talk about how to find the area of a trapezoid. Now, we've talked about what a trapezoid is before, so we know it's a quadrilateral, where what has to be true? Where one set of opposite sides is parallel. So a quadrilateral with one pair of parallel sides. So to find the perimeter, well, that's easy enough. We'd find all the sides and we'd add them up together. To find the area, well, when we looked at parallelogram, we converted it to a rectangle and decided the area. When we looked at triangle, we compared it to half of a parallelogram. We said it was like half a parallelogram, so it was half base times height. So how do we do a trapezoid? Well, let's look at this trapezoid up here. If I look at the midpoint and drop a perpendicular down and cut this little triangle off, it would fit right there. I could do the same thing with the other side. From the midpoint of this leg of the trapezoid, I could drop a perpendicular down, and if I cut that out and taped it on up here, I would get a rectangle. And the area of that rectangle would be this base times this height. Well, you'll notice the height hasn't changed at all, but the base that we're talking about is bigger than this top base of the trapezoid, and it's smaller than this bottom base. Well, it turns out that it's actually the average of the two. So base times height is the average of the two bases times the height of the trapezoid. So my area is 1/2 times the quantity base 1 plus base 2 times the height. So it looks a lot like the triangle formula, except instead of one base, we have two bases that we're working with. This average of the bases, where we go from one midpoint to the other midpoint and draw that, that's called the median of the trapezoid. So if you're ever asked any questions about the median of the trapezoid, that is just that segment that connects the midpoints of the legs, and it's the average of the two bases. Its length is the average of the two bases. So let's do some area problems involving trapezoids. And let's start with a couple basic ones here where we're given all the information. So on this top left trapezoid, I know the formula is 1/2 times the average of the times the sum of the bases times the height. So when I add up the bases here, I get 30. Okay, I'm going to multiply maybe 1/2 times 30 and get 15. Multiply that by 9, and I get 135. Let's try the blue trapezoid. Once again, I average the bases. The bases added up in this time are 56. The order I multiply the 1/2 in doesn't matter. I could do 56 times 18 and then take a half of 56, which is 28, and then multiply by 18, or 1/2 of 18 is 9, and then multiply by 56. Whatever order you do that in, we get 504. Okay, let's try the purple trapezoid. The area is 1/2 times base 1 is 20, but I don't know what that second base is. The height looks like it's going to be 15 though, because it's the perpendicular height, and 15 is perpendicular, where 17 is on a slant, so that is not the height. Okay, so we have to find the height, so let us, we have to find the base. We need to find this length of the base. Well, I know it's more than 20, so I have to figure out how much more than 20 it is. Let's make this into a rectangle and a triangle, where this part is 20, And this part, I don't know yet. So how can we find that? Well, if this is a rectangle now, on the left it's 15, so on the right it's 15. So I could do Pythagorean theorem to find that. Let's see. We get x squared plus 15 squared equals 17 squared. It works out that this is one of those nice, neat Pythagorean triples, and x ends up being 8. Now, that makes this 8, which means the whole base is 28. So I have 1/2 times 48 times 15. I multiply that together and I get 360. So we had to do a little bit more work on that one. We had to do Pythagorean theorem to find that second base. Moving right along. Okay, this orange triangle. Well, let me start the process of plugging everything I know into the formula. I know the two bases, but I don't know the height. Remember, the 12 is not the height because it's not perpendicular. So let's drop a perpendicular down and look what we have. A 45, 45, 90 triangle where the hypotenuse is 12. So in order to find the height, what do I do with the 12? Yeah, I divide by radical 2. But I'm not allowed to leave that radical there in the denominator. So I'm going to rationalize the denominator, and then I simplify my fraction. So 6 radical 2 ends up being my height. 1/2 times, well, that gives me what, 26 times 6 radical 2, giving me 78 radical 2. 13 times 6, take half of the 26 and I get 13 times 6 is 78, and the radical 2 just comes along for the ride. Well, next one, same idea, but in this time we're going to deal with the other special triangle, the 30, 60, 90. Once again, I have my two bases. It's the height that I'm missing. Okay, well, let's see here. I don't know any side of this 30, 60, 90 triangle at this point. So I'm going to have to find one of the sides using the information that we're given. Well, when I broke this down into a rectangle and a triangle, the 12 on top is going to be equal to this section. 24 minus 12 is 12. And now I need to find that height. Well, we're going from the long leg to the short leg on a 30, 60, 90. So we have to divide, we're getting smaller, and we have to divide by radical 3. I get the same problem of having a radical in my denominator. And when it's all said and done, I end up getting 4 radical 3 for my height. Let's combine those bases. Let's see, 1/2 of 4 is 2, so I'm going to get 72 radical 3. Okay, this next one, let's see here. Once again, I would start it off. Things are looking good. I've got 1/2 times 23 plus 37, and then the same problem we've been having, I don't have the height. So I'm going to have to find the height. This is a special case when we have an isosceles trapezoid. The two legs are both 25. And when this happens, what I'm going to do is divide this up into a rectangle and 2 right triangles. Here's why this is going to be helpful. This 23 is going to scoot down there. 37 minus 23 is 14, so each of these parts must be 7. Well, now I can find the height. And what am I going to use to find the height? Yeah, I'm going to use Pythagorean theorem. So let's find that height. So 7 squared plus h squared equals 25 squared. Now I made this problem so it'd be another nice, neat Pythagorean triple. If you solve this out, your height ends up being 24. So let's solve. A half times, what's that going to be? 60 times 24. And that gives me 720. So we have a few left to do. Okay, this next problem, same idea as the last problem. So let's go through those steps one more time. It's an isosceles trapezoid. When it's an isosceles trapezoid, I'm going to break it down into a rectangle with two right triangles. The 14 at this base at the bottom scoots up here. 24 minus 14 is 10. So that 10 gets evenly split along the two sides. Now I can find the height. Pythagorean theorem. 5 squared plus h squared equals 13 squared. And you would work all that out. I recognize that this is another Pythagorean triple. It's a 5, 12, 13 triangle. When you do Pythagorean theorem, you're going to end up getting 12 for that side. The area now is a half. The two bases added up. Whoops, that's a 14. Times that height we just found, which was 12. Multiply that out, and we get 228. Our final problem, giving us the picture and having to find the information, is this blue one. And if we started out, once again, we have two bases, but we're lacking that height because 11 is not the height. Well, what do? We drop down a perpendicular, making a triangle out of it. But I can't use Pythagorean theorem here. And it's not one of the special triangles. So guess what we get to use? Yeah, we get to use trig. So let's find this height. Let's see here. If we go from the 52, h is opposite, 11 is hypotenuse. That's going to give me sine of 52 equals h over 11. Multiply both sides by 11. And that is 8.7. Okay, combine your bases and multiply that out on your calculator. And when I did this, I got 121.8. So we can encounter Pythagorean theorems, special triangles, or trig when we're solving these problems, just like we did with the triangles. Okay, I think we have time to do, I don't know if we have time to do both of these, but we have time to do one more. So let's look at this first example. The area is 60. We have the two bases, and we want to find the height. So let's write down everything we know. The area is 60. The two bases are 16 and 8, and we want to find the height. Well, combining those bases gives us 24. Half of 24 is 12, so our height is 5. And we'll stop there. That's it with trapezoids.